Welcome to SciMOD. This video will show you how to propose, solve and see the results for a wave equation in SciMOD software. We will use the Partial Differential Equation Solver option that permits create and manipulate our equation. This image shows the elements we need to start our analysis. Here is the wave equation that we will use, and also the initial conditions for the problem. To begin, first we open SciMOD software in desktop, and from the options we choose models. Immediately 4 windows will be displayed: Geometry Inspectors, Camera Tools, Analysis Inspectors, and the main window where the axes are, and where we will see our model. To this example we need to add a new window to solve our equation. In the main menu go to Models, and choose General Partial Differential Equation Solver Inspector. In this new window we have to propose our equation and define our variables. Now we create a new case. Choose a name. For example, wave equation. Select on the pop-up button below the analysis type, which is scalar variable, and press New. On the parameter fields we incorporate the respective values for our variables. As you can see from the original equation, we need the second time derivative. So, to the alpha variable we assign it -1. On the respective field just write the value and press Enter. Now to the k variable we will assign it a constant value. So on the pop-up button to k values we choose the first component, give a value and press Enter. Same way before, we choose the k22 field and assign it a value. We can check the values choosing the component we want. The rest of all the variables will be 0, so there is not need to write anything over it. On the constraints part we need to include the variables that we defined before. So basically we need boundary conditions and 2 initial time conditions. First we create our mesh. On the Geometry Inspectors window we choose Geom. Elements on the pop-up button. Meshing, and create a rectangular mesh. Change the node size selecting Identify. Choose Nodes on the pop-up button. Drawing type, and change the thickness to make it easier selecting the nodes. Now we have to select all the mesh boundary. So go to Select option. On Target tab pick Selected. We go to Camera Tools and choose the Pick tool, or just press P on the keyboard, and select the mesh boundary. Once done this we return to the GPDE solver window, and identify with a name this constraint. We call it border. Define it as scalar variable of first type and real part. Finally assign it a value, 0 in this case, and press New to create it. In Constraint Entities choose on the pop-up button Selected, and then press Apply Entities. We will see the total of nodes selected before. Once we define the boundary conditions, it is important to include the initial time conditions. On the GPDE solver window we aggregate a new constraint called Impulse. Select Scalar Variable, and choose in this case the initial time value option. Then real part, and put the value you need. Here we follow the example. So just write the value, and select New to save it. To define this impulse in the mesh, we return to the Geometry Inspector's window and look for Clear Selected button. We go to Camera View and select the point which will represent this impulse. As we did before, on the GPDE Solver window in Constraint Entities, choose Selected and apply it to entities. Finally, let's create the last constraint. As you can see in the example, it will be the rest of the mesh that we did not select before as any of the other constraints, and it is an initial constant time value. So just name it. Select the options as we did before and create it pressing New. Go back to Geometry Inspector's window. We now need to pick the rest of nodes we did not select before. So select the XOR option and in Camera View select the rest of nodes. The software will automatically exclude the nodes selected previously. We return to the Solver window. Choose Selected on the pop-up button and apply to entities this condition. Now we have all the necessary to solve our problem. Getting back on Analysis Parameters tab, we have to add the constraints we created. Choose the 3 of them and add it to the analysis. As you can see, after that, define the time analysis solver parameters as you wish. And press Calculate to start the progress. Here the software will ask you to save the project before start calculating. So save it as you want and we'll continue. A message appears confirming that the project saved successfully, and also a window showing the progress of the analysis will be shown. The Results button will send you automatically to the Analysis Inspector's window where we can see the results to our equation. Before checking the results, we can modify the view to make it more clear. First, on Geometry Inspectors, hide the triad, selecting the Camera tab. Choose Triad on the pop-up button and select None. Similarly, pick Light on the pop-up button and choose a background color. And finally, on Camera Tools, select the Contour view. Now is time to look the results. On Analysis Inspector's window, select on Available Scalar Results the Potential Real option. Then we want to see how it move. So in the Increments tab, aggregate some delta and press forward. And you will see how does our first impulse progress and make the wave travel on the mesh created. Also, to make it more interactive, we can see in 3 dimensions how does it works. Go to Deformation tab. Press Turn On. Select Use the Factor option. Add some amplification and check the box below. Finally, make some changes on the view. And again, start the simulation.